Okay, so we're going to go back to sketching polynomial functions. What is a polynomial function? There are examples on the board. Not necessarily, but often yes. Yep, like this. Tell me more. What do we call these types of graphs? What do we call these types of graphs? Parabolas or quadratics. Excellent. So quadratics and parabolas, same thing. They are a type of polynomial. They are a polynomial that has the highest power of 2. What type of graph is this? It is a polynomial. What type of polynomial? Let's be more specific. No. Starts with a C. U. Cubic. It's a cubic polynomial. How come? Because cubics have this shape. It could be a quintic as well, power of 5. It can't be a power of 4, it can't be a power of 2. This one would probably have something like a power of 6 or a power of 8, something higher. All right. Okay, so we're going to look at sketching those graphs. Now, when we did polynomials the first time, it's in the video that I'm going to post later so you can get the notes from that. When we sketched polynomials the first time, or when we sketched cubics earlier in the year, what were the key bits of information you showed in the cubics? When we sketched these earlier in the year and we said show all the key important features, what were the important features that you put on the graph? Did we put the maximum and the minimum on there? We did put the x-intercepts and we put the y-intercepts on there. So what we did at the start of the year when we sketched these graphs is we left out the maximums and the minimums.
And did we do the endpoints?
We did endpoints. So we've already done endpoints. We have done intercepts. And we have considered the shape. But we left out the maximums and the minimums. And the reason why we left out the maximums and the minimums is because we had not done calculus yet.
Oh, is that like when there's multiple?
When there's turning, we're going to look at those turning points,
Yeah.
right? So we're going to actually use calculus to find exactly the coordinates of the turning points and the points of inflection.
Is that when the gradient is 0? So that's how you work it out?
That is exactly correct. So the way that we're going to find these maximums, minimums, and points of inflection is at all of these points, the gradient is equal to 0.
So are we going to have to like do quadratic working out and polynomial working out for like 0 equals the difference?
Yes. So we're actually going to use the null factor law and all of that factorising and solving quadratics and solving polynomials to work out these values. Because we know at all of these points, the gradient is always 0. So if we now can differentiate to find an equation for the gradient, for calculating the gradient, we can then find out when that equation is equal to 0 to solve those 2 points. Can anyone tell me why do they think it's called a local maximum or a local minimum?
Because that's just what's in the limitation. Like what you'll see. I don't know.
Keep talking.
In the window of the graph. The portion of the graph that you're seeing.
Yeah. When we say it's a local maximum or a local minimum, it's because it's relevant to which part of the graph we're actually looking at. So here, I can't call that the maximum because there's a point on the graph over here that's higher, isn't there? So this is only a local maximum. That point we can't call the minimum or the absolute minimum because there's a point over here that would end up lower. So when we use calculus, we're going to be finding the local maximums or the local minimums, and we're going to do that where the gradient's equal to 0. So let's actually start. I would like you to have a go at sketching this graph. I want you to break out your summary journals. This is a cubic. You should have notes on sketching cubics. All I want you to do at this stage, don't worry about stationary points. Could you please try and sketch that graph by finding the y-axis intercept and the x-axis intercepts? Okay? Go, break out your summary journal, see what you can find. Use your calculator to sketch it to get an idea of what it looks like first. Can you sketch that? You're allowed to talk to each other to discuss it and compare notes. And if you want to move and sit next to somebody else so you're not on your own, so that you can compare notes, please find a friend. Can someone please offer for Ahmed to come and join them? Yep, Tanisha's waving you over. There you go. Thank you, Tanisha, for being inclusive. You shouldn't need to for this one. You can, but it's easier if you don't. Alright, just going to check if the video has the whole port. Oh, turn that around a little bit more. Who feels lost and wants me to do it so that they're not stalling and doing nothing? 2, 3, right, good. Okay, those people who feel confident to keep going. What I want you to remember is the first thing I'm going to do, usually, find the y-intercept. How do I find the y-intercept? Call it out. So I get y equals 9 times 0 squared minus 0 cubed, which is y equals 0. So it follows that we get when x equals 0, y also equals 0. That's one point. How do we find the x-intercept?
Y equals
0 equals 9x squared minus x cubed. How do we solve quadratics, quartics, cubics? Starts with an n. Null factor law. We should always try and use the null factor law. Null factor law says get a null, get the factors. Highest common factor is x squared, which gives me then 9 minus x. So either x equals 0 or x equals 9. Yeah, okay if I just jump to those two from there? Hands up if you know what I did and how I jumped from there to there. Hands up if you don't know how I went from there to there. I need your hand, so I've got to go through it. Thank you for your honesty. So null factor law, when I multiply two things together to get an answer of 0, either the first one equals 0, and if x squared equals 0, then x has to equal 0. So this is one of my solutions. Or the second one equals 0. Solving that equation, I get x equals 9. This is my second solution. So now, when I start to plot my graph, this one tells me when x is 0, y is 0. Same point, not super helpful. This one tells me when x is 9, y is 0. To start to sketch my graph, I know it goes through here, 0, 0, and I know it goes through here, 9, 0. I've only got 2 points. Is it a quadratic or a cubic? It's a cubic. Is it a positive cubic or a negative cubic? It's a negative cubic. So negative cubics go like this, right? Almost off, grab a seat, bud. We're going through that first question on the board. You've come at a pretty good time, really, in terms of things. Okay, if it's a negative cubic, but it only touches the graph at these 2 points, one of them is going to have to be the turning point and the other one's going to be an intercept. All right? And this is because this one is the squared part. That's where my turning point's going to be. And because this one is the linear part, that's where I'm just going to pass through the intercept point. That's going to go straight through. So this one gives me that answer. This one is the turning point. This one is the turning point. This one is linear. This is where I'll just intercept. And it's going to look like that. So then my graph has to go like this. We've already found the local minimum. I don't need to do any work at all to get that.
So how do you find the points if the gradient at both of the turning points is 0? How do you find each
Let's
of
actually have a look at that right now. So what we're going to do, we're going to now find out the turning points because we know that the gradient is 0 when it's a maximum. We know that the gradient is 0 when it's a minimum.
So would it be the same answer?
Well, let's actually go through this because I'll get you to see what it looks like and then you can maybe form a little bit of a hypothesis / conjecture about how you know which one's the maximum and which one you know is the minimum. All right? Okay. To find the turning points. Step 1. Find the equation of the gradient. How do we find the equation of the gradient? Good. Sure. Okay, so we've got y equals 9x squared, no, that wasn't 9x squared, or was it? It was 9x squared. Minus x cubed. Thank you. So let's differentiate that. I'm going to use the dy dx notation, just because I can. Normally when it's a y, I use dy dx to show that I've differentiated. How do I differentiate? What do I do? 2 times 9? 18x. 3 times 1? 3x squared. Okay. Step 2. We make the derivative equal 0. Stationary points occur when the gradient is 0. The derivative is the formula for the gradient. So now I make the derivative equal 0 and then solve it. Okay, how do I solve a quadratic? Factorise it using the null factor law, or you can use the quadratic formula. This one's going to be easier to use the null factor law. Highest common factor is 3x. Either 3x equals 0, in which case x equals 0, or 6 minus x equals 0, in which case x equals 6. So these are the 2 points when the gradient is 0.
Do you need to find more?
So here's one of them, 0. Here's the other one, that's 6. Now, how do I know which one's a maximum, which one's a minimum? Your textbook, if you follow your textbook, it talks about drawing sign diagrams and does this strange thing. Don't do that. 1, it's not in the curriculum. 2, it's pointless and takes a long time and not required. You should be able to have an idea of what the graph looks like and then substitute in some values to work out which one's bigger than the other in terms of working out which one's the maximum and the minimum.
And
All right.
how do you get the 2 y values?
Now, how do I get the y values? The y values come from this formula right here, don't they?
Oh, wait, so you're just going to sum in either or?
So this formula will tell me what y is when I know what x is. And we know where we're trying to find out what x is. Now, there's no point substituting in this one, is there?
No.
We already know that coordinate. We already know that coordinate. It's going to give me 0, 0. I do need to substitute in this one to find out the y value. So step 3, sub into original equation to find the coordinate. Which looks like this. Y equals 6. No, it was 9, wasn't it? Forgot what the original equation was. 9 times 6 squared minus 6 cubed. Who thinks that is unfair to have to do by hand? Year 12 examiners will not think that that's unreasonable to do by hand. You could potentially get a question to have to do that by hand with no calculator. So be prepared to work that out. Have some strategies to work quickly so it doesn't take you 5 minutes to do that. All right. 6 squared equals 36. 6 cubed equals 216. 9 times 36. Just do 10 times 36 and then minus a 36. So it's 360 minus 36, which is 324. And then we need to minus 216.
If you like ran out of time and you wrote that, would you still get mark?
Depends on the marking scheme. So this coordinate, hopefully I did that correctly, is 6, 108. Got that as well. All right. What I want you to do, I want you to do this question in your book, and then you can start some practice questions. So I want you to do that one. Show me your answer, show me your beautiful graph, and everything done lovely. Once you have done that, you can do some practice questions of your own. You've got to go? No. Done now. Ho ho, look at you go.